All right, then let's get started. All right, so it's about 7 p.m. in Singapore and noon in Dublin. Let's get started. Okay, so recording is on. Okay, hello everyone. Good evening to those who are joining from Singapore or in the similar time zones, and good day for the audience from other parts of the world. Welcome to the keynote speak of the Global Research Forum on this topic called the fruitation and challenges of computational social sciences, jointly hosted by the Faculties of Arts and Social Sciences and the Departments of Information Systems and Analytics of School of Computing at National University of Singapore. I'm Chen-Chieh Feng from the Department of Geography here at NUS, and I'm also a co-organizer of this forum. Okay, so today is my honor to introduce Professor Rob Kitchin from Social Sciences Institutes and Geography at the National University of Ireland, Maynooth. Just a very short intro. A geographer by training, Professor Kitchin's research interests have covered issues related to various aspects of mapping, and later the intersection of technologies and society, including building the technologies such as the dashboards, and at the same time critically reflecting on the issues relating to politics and ethics and other issues. So in this direction, he has published widely across the social sciences, and I hope that I got the number right, which include 32 authored and edited books. And recently has published a book titled Data Lives and How Data Are Made and Shape Our World. And on top of the book chapters and books, he also published over 200 articles 200 articles and book chapters. So today, Professor Rob Kitchin will give us a presentation for about 1 hour and followed by a Q&A session for about 30 minutes. So the title of the presentation is the Epistemology, Praxes, and the Politics of Urban Science and City Dashboards, which include 3 components: the critically examining the conceptual understandings and the practices of urban science, the city dashboard, and the critical framing and application of urban science. So without further ado, let's welcome Professor Kitchin for his keynote speech. And Professor Kitchin, the floor is yours.
Okay, thanks very much for the introduction and for the invitation to speak today. So yeah, I'm gonna talk about kind of epistemology, praxis, and politics around urban science as a particular form of computational social sciences. If you see me looking over the top of the camera, it's because I have 2 screens, and my slides are above the camera on my laptop. So I'm not sure I'll actually speak for the full hour either, but we'll see how we get on. So I'm going to start by talking about urban science and what I kind of conceive of what urban science is. So it's really a kind of a computational approach to city systems and the processes of urbanization. So it's a kind of a computational social science approach onto urban systems and urban processes. And it's really using kind of urban big data, so data that's typically produced in real time. So it has a velocity and it's typically exhaustive to a system. So, it's looking at every single car on the road network or every vehicle. It's looking at all the regions off of sound sensors. It's not a sample. It tends to try to move towards n equals all where it can, and applying data analytics to those kinds of data. So various forms of data mining, pattern recognition, statistics, visual analytics, modeling, simulation, and so on, to try and identify causal relationships and also to predict how city systems work. So this is a kind of a very typically a very quantitative approach. It can involve qualitative data, but it's typically taking a computational approach onto that qualitative data. So things like sentiment analysis, for example. Now it builds on a much longer history of kind of quantitative social science. So things like quantitative geography, geographic information science, urban modeling, social physics, urban and regional economics, urban cybernetics, going back into the 60s, social ecology, urban informatics, location theory, and so on. So there's a kind of a rich history of kind of quantitative approaches onto the urban, going back a long way, given a boost by the kind of turn to digital computing from the late 50s, early 60s on. So you see the first kind of land transport models, computational models back in the kind of 50s, 60s. As Mike Batty has kind of argued as well, though, that one of the issues around urban science is it's not always cognizant of that longer history. That's partly because the practitioners are not coming out of those disciplines. They're coming out of maths, comp science, data science, and so on. So they're not necessarily embedded in the domain knowledge or the history of these kinds of techniques, and so on. I'll come back to that as an issue later. So the aim is to conduct extensive analysis of systems. So typically sees the city as a set of systems, to try and determine urban laws and identify relationships within the data to be able to produce new theoretical insights. Urban science itself has been kind of set up or promoted as of a notion of trying to develop a synoptic or integrative science of cities. And it's also often has a very practical application in terms of trying to translate knowledge into products, into policy, into the work that city managers and others do. And a lot of urban science projects often have partnerships with industry and with the state within the project framework. And that kind of contrasts to urban studies, to urban science in a way is kind of set up as oppositional to urban studies, which obviously has a much longer history going back into the 19th century and so on, and which tends to conceive of cities as a kind of constellation of places as opposed to a system of systems. Typically we'll use kind of qualitative, quantitative methods on small data. So typical kind of data sets that existed prior to big data. So it's often sampled data. It's often at particular time in particular places and so on. And it's much more likely to have a historical grounding and a more contextual approach. So with respect to things like politics, culture, and history. So it tends to try and frame things in a bit more of a kind of historically grounded and contextually kind of situated kinds of analysis, as opposed to a kind of running models that are then interpreted outside of that context. Now, it's epistemology is not exclusively, but typically is kind of rooted in a more kind of positivistic tradition. So it's kind of taking ideas from scientific principles and the scientific method, drawn from kind of natural, hard computational sciences, and applying them onto social phenomenon in order to explain them. Okay, so there's a kind of the epistemology basically draws from that kind of scientific framing. It's typically approaching this through statistically testing relationships between variables, or trying to build models to produce and verify laws that can explain and predict how systems work, and to formulate theories which can be tested and verified, which obviously fits within the kind of scientific method. It's typically adopting a realist epistemology, which basically means that it would conceive of the existence of an external reality which operates independently of an observer and can be objectively and accurately measured, tracked, analyzed, modeled, and visualized to reveal the world as it is. Okay, so there's a sense of which the observer and the observed are distinct from each other, and that you can objectively, neutrally, value-free generate data that is representative of that world and can be used to make sense of the world, free of any kind of subjectivity or bias or values and opinions and so on of the observer. So there's a form of mechanical objectivity that can be applied in the analysis. There's typically kind of three epistemological variations in relation to this. So the first is a kind of traditional hypothesis-driven deductive scientific method, with the questions and approach guided by established theories. So that's the kind of traditional quantitative social science approach, right? You set up your theory, you test it, and you either verify or falsify it, and so on. And you're driven by hypotheses. The latter two have really been driven by big data analytics, and a kind of more recent epistemological framings in relation to that. The first is a kind of inductive empiricism, in which data analytics enable data to speak for themselves, free of theory or human bias or training. So I guess the most famous article in relation to this was Chris Anderson's The End of Theory, which is basically, you know, if you can throw enough computation at the data will reveal the world to you, free of having any theory about it. There'll be a kind of inherent truth in that. I'm sorry if you can hear my dogs barking like crazy. There's a tractor going past, I think, and they've gone slightly nuts. And the last is a kind of a data-driven science, which still holds on to the tenets of the scientific method, but sticks a kind of exploratory data approach at the front of it, by which the kind of hypotheses for being tested are generated from the data, as opposed to being generated from the theory. It tends to use a kind of a guided approach. So there's a kind of a backwards and forwardsing then in relation to established theory, and then selecting out how you want to proceed. So it kind of adds a step at the start, and then goes back into the traditional kind of scientific method. And that's really, the latter one is really the main approach that's developed in a lot of the sciences in relation to big data. There's still quite a lot of inductive empiricism, I think, within a lot of data science, as opposed to, say, within the biosciences or within the social sciences and so on. So that's the kind of how I would see what urban science is as a kind of as a field or as a discipline, and kind of how the epistemology is kind of set up in relation to that. And I'm going to kind of talk through some of these kinds of ideas, and I'm going to discuss it in relation to city dashboards. And just to kind of give you an idea of some of the kinds of data that would typically be used, and some of you will no doubt be very familiar with this. A lot of this is kind of coming out of smart city technologies, where these kind of technologies that are being used to manage and govern cities now, where they're being embedded into the fabric of cities and layered onto the top of infrastructures as ways of monitoring and controlling them. And they cover a whole series of different domains. So you'll get within government, things like e-government systems, online transactions, city operating systems, performance management systems, urban dashboards, security and emergency services, things like centralized control rooms, digital surveillance, predictive policing, and all kinds of different kinds of policing data, and coordinated emergency response, kind of transport, things like intelligent transport systems. So using networks of inductive loops, cameras, sensors, transponders to monitor the movement of public transit, and so on, feeding back data into a system that then uses the data to phase and configure the traffic light sequencing, integrated ticketing, smart travel cards, bike share, real-time passenger information, smart parking, logistics management, and so on, into energy with things like smart grids, smart meters, smart lighting, and so on, into waste and around things like compactor bins, dynamic routing, collections, into environments, all kinds of sensor networks measuring pollution, noise, weather, land movement, floods, and so on, into buildings and building management systems that are measuring how the building is used, the energy usage, the system usage, the conditions within the buildings, and and so on, into individual homes and smart meters and app-controlled appliances, into the civic domain and various kinds of apps, smartphone apps. A lot of data being generated off the smartphone, some of the data becoming open data and so on. Now, all of those different technologies are producing real-time data. So they're producing, and they're typically working towards n equal all systems. So it's typically measuring every bike on the network or every bus on the network. If we're looking at transport, it's measuring every car on the network. If we're using things like automatic number plate recognition cameras and so on. So it's generating huge amounts of data, all very useful and interesting data about how various systems are working and functioning, how the infrastructures are functioning. And that data is obviously a huge resource for researchers who want to try and make sense of the city and how these various systems are working. And the data can also be used to create further applications that can then feed back into these domains. So, obviously new techniques around things like predictive policing or security controls, or, and obviously a lot of this kind of technology, some of this technology being repurposed during things like COVID to monitor the kinds of movements of people and to police and control those movements and so on. So kind of new, that would be an example of new applications of some of this data back out into urban management and so on. If you're familiar with this data, then this kind of information will be familiar to you. So just to give you a kind of a sense of some of this data. So these are just all transport data. These are all data that we've had access to and we've had in our dashboards. So we have public transport data. We have some of the data at the various stops, so the real-time passenger information, movement across the roads, counting cars with the inductive counter loops, car parking spaces, so how many cars are going in and out of the car parks, where all the flights are, the flights arrivals, where all the boats are in the harbour and on the river and so on, what's happening with the bike share and CCTV on the road network. And then just kind of thinking around things like the spatial granularity, the spatial coverage, and the temporal granularity. So this is typically at individual level. So we have GPS point data. So it's either at the junction or where the vehicle is or so on. Some of the data is national, some of it's global, some of it is very localized. And then the temporal granularity is, is the update is every minute, every few seconds, every 2 minutes. We don't know for this, but it's likely every second. It's 2 minutes, less than a second, a minute, 5 minutes, 5 minutes. So this is all data with a very fine spatial and temporal granularity, much finer kind of granularity than we've typically had in the social sciences up until the last kind of 10, 15 years. But the data is not indexical in the sense of we don't have it tied to individuals. So this is all kind of anonymized, de-identified data, and we typically have it we could typically display it in an aggregated kind of form or a de-identified form. And I'll come back to ethics questions later, but clearly there are ethics questions here around fine-grained indexical level data that allows you to track individuals. And then that data feeds off into these kinds of urban analytics and into applied uses of these urban analytics. So these are just some examples of kind of city dashboards and data that's kind of displayed either to those managing the city or in some cases to the public. And a lot of this data can be pulled together and so on. So probably the most famous of these control rooms and that most writing about is this top left one, which is the control room in Rio de Janeiro. It's taking data from 32 different city and state agencies and 12 private concessions, which are mostly energy companies or transport companies, so that people running the buses and so on. And it's pulling them all into a single control room. It's staffed by 400 people working on 3 shifts over 8 hours. It has a media center at the back of the room, so journalists can sit there and see what is kind of unfolding in the city. They can see the car accidents, they can see the fire, they can see the landslides, and so on. City workers in the city have computers that can link backwards and forwards, and they can upload data and they can pull down the data if they're in situ, and so on. The middle one is a kind of control room for a smart district in Tokyo, and you can see some of the kind of dashboard kinds of analytics on here. The bottom left one is a traffic control room for Dublin. I can't remember where the middle one is for. The bottom middle one is for. And then this might be some of the information that might go out to people in the city themselves to see some of this data. So this data is being used to kind of manage the city in real time, which is often not what we as researchers typically do, and we're trying to understand is to maybe take the data that they're using for real-time management and to try and make sense of it, and to maybe create new models or refine models that then might feed back into these control rooms that might enable them to do to kind of understand urban processes and to manage them in a particular way. Now, some of that data will go back out to the public, and some of it will go out to researchers, and I'll come on to access to the data a bit later on. But a whole series of different cities now have been looking at how they can share some of this data back to the public to help the public make choices and decisions in relation to how they interact in the city. And this is some of the work that we've been doing over a number of years now, developing a couple of these dashboards, and I'll just briefly highlight a couple of them. So the Building City Dashboard project ran from 2016 to 2020. And what we were trying to do was kind of look at the politics and practices of these dashboards, and also the design. So there's kind of HCI components in this, there's data literacy components in this, there's design, urban informatics components, and so on. And we were trying to redesign or think through how we go about building these dashboards for different types of constituencies. So from the general public to people who maybe work in policy to people who are professional data analysts, and they're very different types of users, all trying to use a single dashboard. Now I'm not going to go into that today, and there's a bunch of papers that people can look at around kind of dashboard design and so on. It's just to kind of illustrate some of the kinds of work that we've been doing in relation to this. We've also been looking at how you can push this data into different environments that are not the smartphone screen or the tablet or the desktop screen, so pushing it into 3D. So we have a virtual model of Dublin, kind of 7 kilometers by 4 kilometer model of Dublin, quite detailed virtual model, and we've been trying to look at how you could visualize some of the data within 3D and kind of interactions around that. Both in VR and AR, so one where you can kind of see the real world and the model at the same time, one where it's purely immersive, and kind of different data displays around that. And then we've also been looking at kind of map projection kinds of work. So this, I don't know if you can see in the middle one, this is a 3D printed model. So a 3D printed model of the city. It's at a scale of 1 to 2000, so it's 3.5 meters by 2 meters wide, so it's quite a large model. And then we're hanging a data projector, so you can see on the top left, hopefully you can see there's a data projector hanging off the ceiling, projecting the data down onto the model. So this is a kind of a different experience to having the headset on. You can have several people kind of standing around and walking around that model and kind of talking about what's going on, and then we kind of project different versions of the data onto that model, and we can do that to the top right one. You can see we can map the data onto individual level buildings, and I think there's 59,000 buildings in the model. So if we have individual level data, say individual energy data or building usage data, we can project that on. So that's the kind of some of the kind of dashboard kind of work that we've been playing around with, and thinking about what you can kind of do with these kinds of dashboards, and some of the kind of politics and praxis around them, and issues around the data, and so on. And that's what I'm going to move on to now, is to kind of consider kind of city dashboards. So city dashboards basically provide a visual means to organize and interact with data, and they effectively act as a cognitive tool that kind of improves your span of control over very large amounts of data. So it's they basically synthesize and display huge amounts of data in more simple forms, whether that's through graphs or maps or various kinds of visualization, and data that's often quickly translating. You might have lots of different variables, and you've got these different real-time feeds coming in, and so it kind of lets you handle those data and to quickly get an overview of the various trends that might be going on. So it kind of lets you kind of explore the characteristics and structures of data sets and to interpret various trends. Their kind of power and utility is they kind of show in detail and often in real time the state of play of cities. So you can kind of see what's happening with environment or the traffic or whatever real-time data you have or what's going on in cities. And you can put them into longer longitudinal views. So you can put them into kind of a time series view that lets you see, how this compares with a week ago or a month ago or 6 months ago or a year ago or 5 years ago or however, whatever time frame of data that you have. Some of the kind of selling point is this idea that you can kind of translate the messiness and the complexities of cities into kind of a rational, detailed, systematic, ordered forms of knowledge. So it kind of gives you a kind of high level kind of overview with enough detail that you can see the various trends, and it kind of enables us to know the city as it actually is through data that's objective, trustworthy, factual. So this is data coming off of sensors and cameras and transponders and so on. So it gives the impression of being kind of objective, trustworthy forms of data. And what I'm going to do for the next part of the talk is basically take ideas from critical data studies and I guess critical algorithm studies and other areas that have been kind of thinking around some of these issues and use them to reflect on some of the things around dashboards in relation to 6 issues. So I'm going to look at epistemology again. I'm going to look at scope and access. I'm going to look at veracity and validity, usability and literacy, use and utility, and ethics. And I'm going to kind of pose them as 6 questions that are kind of designed to kind of expose and to tease out some of the politics and practices around these city dashboards. And I'm going to propose that you can use these kind of questions as heuristics for looking at other data-driven technologies as a way of kind of thinking through maybe some of the kinds of issues around the approach and around the use and application of some of these kind of urban science or computational social science approaches. So I'm going to start with epistemology. So the kind of question here is kind of, how are insight and value derived from city dashboards? So the epistemology typically within these dashboards is a reliance on visual analytics. So they're highly visual. They're using graphs. They're using maps. They're using 3D spatial viz. They're a form of spatial media, basically. They're typically adopting a realist epistemology, so they have the separation of observer and observed, and they're taking the data to be representative of what it's meant to be displaying. So there's a clear correspondence between the data you're being viewed and the world as it is. The urban data are effectively being cast as being neutral, value-free, objective, and essential in nature. So the essential in nature is that level of representativeness. And when they're analysed in objective ways, then they reveal the truth about cities. So they're seen as kind of displaying the city as it actually is in a meaningful way that can be interpreted and used in confidence, basically. Now, from a critical data studies perspective, all of those assumptions would be challenged at some level. So they would challenge this notion that of a separation of observer and observed, that you can that the method or the data doesn't influence or doesn't shape what's happening, and that the data themselves are kind of neutral, objective, and representative. They would challenge those kinds of assumptions. So from a CDS perspective, data are produced. They're not collected. They're things that are manufactured that involve choices and decisions about how you set things up, about what you do and you don't measure, how you do and you don't measure them, how you calibrate them, and so on. So even a thing like a sound sensor might seem like it's a very objective, neutral thing, but there are big decisions made about what kind of sound sensor you invest in, how you calibrate it, where you locate it. There's a big difference between putting a sound sensor in a park and putting it on a major junction. There's a whole politics involved of where you locate those measurements. There's a whole set of questions around how you noise sensors typically produce noisy data. There's a lot of error, and you kind of get a lot of these kind of fluctuations of the data. So there are real questions there around how you kind of smooth that data and so on. So there's all kinds of choices and decisions and kind of politics involved in how that data is handled, and it's not as kind of objective as it's first portrayed. There are all kinds of values and decisions being made. So these are not kind of necessarily neutral, commonsensical tools. They actually constitute a kind of a socio-technical assemblage, both the dashboard itself in terms of how it makes decisions about how it wants to display the data, and you can make all kinds of different design choices. You can make all different choices around how you categorize the data and how you display the data, and so on. And I'm gonna show you the idea of a data assemblage in a second. There's a sense of which these act as translators and engines rather than mirrors. So these dashboards don't just mirror the world; they actually make things happen in the world. You know, people view these dashboards and then make decisions based upon what they see, and so they don't just reflect the world. They shape our thinking about the world, and they shape our decisions about what we do. They're often quite simplistic in terms of what data is displayed and how it's displayed. And what that tends to do is it's quite reductive. It atomizes what are often very complex contingent relationships. And then lastly, it decontextualizes the city. So what you see are these patterns of data, but they're completely divorced from the longer history that has led to that data being produced in the first place. So you're seeing the kind of graph outside of any knowledge of the history of various kinds of policy related to that, or the various kinds of path dependencies that have led to that kind of situation arising, and so on. So it tends to produce interpretations free of context. Okay, so there's some of the kind of epistemological issues around how these kinds of dashboards kind of work. So this is a kind of assemblage, and this is where some of the politics and the practice, both in relation to dashboards, but also the technology that's producing the data that goes into dashboards, kind of comes from. So on the one hand, in this column, we kind of have kind of systems and processes. So this is effectively the technical stack, you know, from your infrastructure and hardware through your operating system, through your database, through your code and your algorithms, up to the interface and up to the user. And there are all kinds of decisions and choices being made across all of these that have effects on what data are produced, how you analyze them, how you make sense of them, how you interpret them, and what kinds of happen. So changes in all of these have effects. And then the context is what kind of frames that system and task. So there's all kinds of systems of thought, so ideas and approaches, principles, ethos, and so on, various forms of knowledge. So our training as people who develop the technology and so on, through to finance. You know, if you're in an open data, open science project, that's quite different from if you're in a for-profit kind of project. And the finance influences the kinds of choices and decisions you make about what kind of project you're doing, what kind of outputs you're trying to create, and what you're actually going to do with that knowledge when you get it. Various kinds of political economies, various kinds of governmentalities and legalities. So things like standards, protocols, regulation, law, and so on, they all have an influence on what's kind of produced. Organizations and institutions, so the ways in which different epistemic communities work and operate, and the ways in which state agencies and companies operate, and so on. So we have a paper on the Dublin dashboard which talks about this. So, you know, kind of liaising with Dublin City Council, there's a whole series of politics around getting access inside that organization and what kinds of data you can then get access to, what they will approve of, what they'll block, what they're hoping to achieve versus what you're hoping to achieve. There's all kinds of negotiations and so on that go on that actually shape the final dashboard and shape what is displayed and how it's displayed, and so on. And then obviously there's a kind of a marketplace into which this is going, which is to the general public, or its policymakers, or its universities and researchers, or its companies, and so on. Because the same kinds of data that are going into these dashboards is often going into company initiatives. Okay, so we can also kind of think around the critique of the epistemology of urban science more generally, rather than just in relation to dashboards. So these are some of the kinds of critiques that have been kind of leveled at urban science, and in many ways they kind of mirror the same kind of critiques that were leveled onto quantitative social science, quantitative geography, geographic information science, and so on, which is basically they're too reductionist, mechanistic, essentialism, and deterministic. They take very complicated systems that consist of very diverse individuals, multidimensional social structures and relationships, and they kind of collapse them into these abstract data points and universal formulae and law. So there's a kind of an epistemic violence happening in where you take the variation and you collapse it down into kind of more simple models, and so on. The second is it's not objective, neutral, and value free, but is framed and situated within these kind of wider power geometries and knowledge and practice, and that there are all kinds of choices being made around the kind of data generation, the forms of analysis, the interpretation, and so on, that these can't be kind of just simply separated out. There are inherently kind of politics involved in those. Thirdly, that it really just concentrates at this kind of empirical, factual level, and the kind of the positivistic approach basically willfully ignores metaphysical aspects of human life. So, and that's obviously a trait of positivism, right? So positivism wouldn't would ignore kind of metaphysical aspects, so values, opinions, beliefs, and so on, because they're not easily measurable, they're not easily verifiable, and so on. So you stick to the factual, basically. But of course, a lot of lived life in cities is at the level of the kind of personal, subjective, metaphysical, values, opinions, beliefs around our political choices, our views around what we're going to protest about or what we're going to accept, and so on. And it tends to cleave off things like politics, ideology, social structures, the role of capitalism, culture, and so on, in how cities operate, how they're experienced, kind of what, how they function, and so on. And it reduces it down to this kind of very factual, operational kinds of data and approach. And that's and it kind of promotes this instrumental rationality that posits cities can be effectively steered and managed through scientific insights and technical instruments, and that urban issues can be solved through technical solutions. So a lot of smart city technology is obviously based around this kind of technological solutionist idea that, you can kind of create this technical system, you feed in the data, and you can solve the problem. And at one level that seems quite nice and straightforward, but it does cleave off all this kind of politics. It does cleave off kind of contestation, all the kind of wicked problems that are not easily captured or steered. And it tends to push away other kinds of solutions, so that are often best solved through political or civil society or fiscal or policy or legal interventions rather than technical fixes. So you can approach things like traffic control and congestion through a technical system that's designed to optimize the traffic on the network. But all this is a sticking past a solution to something that's actually a more fundamental problem around, the real solution to congestion is getting people walking, cycling, and onto public transport. It's not optimizing. It's not optimizing the problem. You're not fixing the problem. You just have a sticking plaster solution. And often you need a more holistic response that involves technical fixes, yes, but in conjunction with political solutions, civic society solutions, fiscal solutions, policy solutions, and legal regulatory solutions. They can't be separated. So, smart cities technologies only typically work if they're accompanied with other kinds of solutions. So they're kind of a same kind of thing with other kinds of problems, right? Like housing and homelessness. You're not going to fix homelessness with an app or by optimizing management of homeless services. Like homelessness is a problem of deep structural inequality, mental health issues, domestic violence, alcoholism, a whole series of various kinds of social problems that need social interventions. A technical solution is not going to fix that. Okay. If you want to understand Kabul right now, you're very unlikely to do it with an urban science model. It's a problem of politics and culture and international relations and all kinds of messy stuff, right? So that's kind of what I'm concerned about. This other kinds of stuff having to be there, and an urban science approach can't replace an urban studies approach. They have to be used in conjunction from my perspective in any case. And the danger is that or the accusation is it produces quite limited and limiting understandings of how cities work, and they foreclose what kinds of questions can be asked and how they can be answered. So that's not to say you shouldn't do urban science, and obviously I try and do urban science, but I'm also kind of cognizant of the limitations of what you can do with urban science. Some of the other kinds of critiques is that some of this kind of work is outside of the domain. It lacks domain knowledge, and it also lacks a kind of a history of urban policy and planning and what's kind of happening. So again, this is kind of critiqued by somebody like, Mike Batty, for example, has made this kind of critique. I mean, he himself is an urban planner. He started in urban planning 50 years ago. He has deep domain knowledge around urban planning. He's not just an urban scientist, and he and I think he's right. I think part of the problem with a lot of data science and data analytics is the people practicing that don't necessarily have deep domain knowledge around the area in which they're working in, and that's a problem. And it's really an issue around linking up people. So you don't necessarily need people to gain the domain knowledge, but you definitely need them to work with people who do have the domain knowledge, who could say, yes, we tried that 25 years ago, and this is the reason why it all failed. You see this all the time. If you're ever a judge in a smart city hackathon, and you kind of go around the tables and talk to people, and they're coming up with solutions, and you're kind of saying, yeah, that's fine, but we tried that 10 years ago, and these were all the issues. Or you do know there's a whole history of interventions that have been looking at this. Maybe you need to go and have a look and learn from it, as opposed to this very future orientated with no past looking back, just looking forward, as if you can solve real world problems today outside of any context, purely by looking at the data coming off. And in my opinion, it's a problem. Okay, so move back into my six things. So to move to the second one, I've no idea how I'm getting on for time. Okay, so scope and access. So dashboard, process, and display quantitative data, generally reoccurrent, so they can be tracked over time and space. These are longitudinal data that are generated on a fairly continuous basis. Not necessarily always in real time, but certainly every month or every quarter or every half year or year. At the same time, there is a massive amount of data about cities that are missing and are in fact incredibly difficult to get. And we've done a number of data audits for the city and so on to try and find out what data are available. Trying to find spatially granular, temporally granular data can be a problem, and you might only end up with 5 or 6 indicators in each domain, not necessarily dozens. So loads of things about the city are missing from these dashboards and are never going to be there because the data just simply are not generated. So they automatically give you a limited view of what is happening. You don't have any metaphysical data, obviously. You don't have any of the kinds of intangibles, values, opinions, beliefs, principles, ethos. You don't get any of that kind of data into the system. So there's significant gaps and silences there. There are also questions around how accessible the data is to the public. Some dashboards you can see the data, but you can't access the data. Some data is just available to the policymakers or into those control rooms, but not to the public. You can get big variations across administrations and across places. So I could probably get more data if I was to move up into Northern Ireland and move to Belfast than I can get in Dublin and the Republic of Ireland. And we had enormous difficulty getting access into the data. And we also had difficulty maintaining access to the data. So things like broken APIs, data sets being discontinued, the methodology for generating the data changing. So the time series becomes a problem because there's a break in the time series. And even when data are available, there are often issues related to the data form, the data formats, metadata, data standards, modes of sharing, and so on. I think I can, and that can vary quite significantly across cities. So you can have very fractured data landscape. This is probably not an issue in Singapore in that you have a unitary city government, but where it becomes a real problem is where you have a city with a very fractured political landscape. So in Dublin, we have 4 local authorities who run the city. They're all autonomous, which means they run completely independently of each other. There is no body over the top. So there's no like regional government over the top of these 4 local governments What that means in theory is you could have 4 separate bike share schemes that are non-interoperable. You can have 4 different open data sites. You can have 4 different whatever it is. This is the map here is actually of Boston. This is metropolitan Boston. So I think it's 3.2 million people. Metropolitan Boston consists of 101 autonomous towns and cities, which basically means there's 101 planning departments, there's 101 school districts, there's 101 waste and water departments, there's 101 police departments. They are all completely autonomous. They don't share data with each other. They don't interact with each other. They have different data ontologies. Most of them don't have open data sites. If they do, it's typically federal data rather than local operational data. It's actually quite difficult to produce city-wide data analytics for that area. This is actually the city of Boston, which is right in the middle, and this is like Cambridge, Somerville, and Brookline, and so on. The city of Boston's evacuation plans in case of emergency go to this border. They don't go to this border on the edge of the city. They go to the next town, and then they stop, and they don't have any data for this place. You're on your own to get out the rest of the 10 kilometers out of the city, and so on. So you have a highly fractured data landscape, which makes doing urban science in this space actually quite difficult. And if you look at a lot of the urban science done in Boston, it's typically actually of the city of Boston, this one part in the middle, or in Somerville. Somerville has a data analytics department. Cambridge has some, and has started doing some open data. Most of the rest has none. So highly fractured, and then fractured across stakeholder groups as well. So, various different state agencies or NGOs or companies or other people who might have data sources. Okay. So that clearly makes a difference to kind of what kind of science you can do, and then also around the validity of your interpretation of those findings. If you've only got one part of the city, then and then you're making conclusions around the whole city, then you're into ecological fallacy problems. And I'm going to come on to those in a minute. There are clearly issues with the data. So this kind of idea of this kind of objective, neutral, value-free, representative data, in reality, there are problems. And all of you working in computational social sciences will know this, right? You will all be doing data wrangling, data cleaning, playing around with the data, restructuring the data, trying to clean it up, trying to improve it, and so on. So, there's instrument and human error and bias in the data. There's issues of abstraction and generalization and representation. There are issues around calibration, and so on. The data being generated, you have various technical instruments for this of varying specification and parameters. So how you set the parameters and so on. It's actually quite a nice paper by I think it's David Ribes, where he looks at the data coming from a water sensor, I think over 30 or over 50 years. And the water sensor changes, so they keep replacing it, they keep updating the sensor. And then his question is the data the same over the 30 years? Is the sensor that the person had to go to every day, 3 times a day, and write down what the measurement was against this kind of new fancy data sensor that automatically produces the data and sends it back? Are they really measuring the same thing? Are they really of the same quality? Are they really of the same parameters and so on? And there's real kind of questions there around some of the time series around these data and around the calibration and the quality and veracity of some of this data. So questions around scientific behavior and organizational processes around how the data is treated and processed, and so on. A lot of the data is published without metadata. So this is a major issue for us in producing our dashboards, is you just get given the data and you're basically told to trust it. You don't have any metadata really related to it. So you have very little information around methodological transparency about the exact method through which the data was generated, the exact specification of the technical tools, the exact form of calibration that was used, or the cleaning processes that were used on the data. You don't often have information around the sampling frame or the handling, or you don't have data around the levels of error or bias or uncertainty or reliability. You often have very little around the lineage. I mean, we were literally just given access onto APIs or our access onto maybe Excel spreadsheets and very little else. And so we did quite a bit of kind of investigative work trying to look at this. And so this is a summary, again, going back to these data of the public transport, the travel, the car park, spaces, inductive. And then we've got different types of, if you like, data quality measures across the top. So sustainability, reliability is like how kind of stable is the data set? Like if I go there in 5 years' time, is the data still going to be produced? Is it still going to be produced in the same way? You know, so this is a paper looking. This is from a paper looking at whether we could use some of this data in new official statistics. So could you produce new official statistics for the city? Now reliability is typically official statistics. You want the same thing being measured in 50 years' time or 100 years' time. Like this is long-term statistical production. So you know, is the stability, is the reliability in what's being measured? Is the transparency and interpretability? Is the things in place for privacy? Then things around, so this is around the source in relation to data. So things like fidelity, the cleanliness of the data, the completeness of the data, the coherence, and then around metadata, you know, metadata availability, information about change over time, information around standardization or whether the data is standardized, issues around methodological transparency, and issues around relevance. So relevance is really, is the data fit for purpose for the use for which it's being put? And you can see we got good against some of these. So we went back and tried to assess these. So we kind of played around with the data. We interviewed the people who produced the data. We basically tried to fill in all the gaps and then make some assessments. And you can see that a lot of this data is kind of fair or not ready, or in some cases poor, and there are none that are really good all the way across, which suggests that there's difficulties with using them for official statistics, because you really need all of these for those. So if I'm going to produce an interpretation off of this data, then there's inherently some kind of question around the veracity of the interpretation that I draw from this data. Now, that's not necessarily a problem, because there's issues of veracity on every single study ever done in science on the planet, right? So that's not inherently not an issue. But if a lot of those things are poor or fair or not ready, then there really are some substantive issues. So again, there's kind of issues around the appropriateness of the method and the methodological issues around producing some of the data. There's obviously issues around validity of the analysis and interpretation. A lot of this stuff is algorithmic black boxed. And so you can't see the scrutiny. So this is why we're having difficulty with some of this data, was because they're black boxed and we couldn't see the technical instruments. We couldn't see the processes. We didn't know what standardization or calibration and so on. They weren't available for scrutiny. And then a big issue within dashboards actually is around ecological fallacies. And so how the data is presented makes a big difference to how it's interpreted and what conclusions you could draw from the data. So the data on the right, the three maps on the right here, are actually all the same data. They've just been displayed at three different scales. The top one is electoral districts. So this is unemployment rate for an electoral district in Dublin. The area in red is basically over 35% unemployment, I think, or over 40% unemployment. So this area in the bottom left looks as if it's a problem. And it looks as if it's a problem if we do it at a numerator area. And this area here that's in blue here suddenly becomes red. So it starts to look like a problem and so on. And then when we get it down to small area, so this is typically 2,000 to 3,000 households, this is 200 to 400 households, and this is 80 to 100 households. And you can see this big area at the bottom is now swapped to blue, which is under 5% unemployment. Up here, it's over 40% unemployment. If you were doing a target area initiative, that area looks as if it's ripe for an intervention. on this map, it's quite clear it needs no intervention. Okay. There's nothing has changed other than the scale of the data being presented. This is a typical ecological fallacy problem. And actually, it's a very thin strip of this neighborhood that has very high unemployment that needs some intervention. So these areas in red on here to also disappear and so on. So how you present the data in the dashboard makes a big difference to how people can then interpret that data and then what they do on the basis of that data. And so that's also one of the things we've been kind of playing around with. And we've also been looking at temporal ecological fallacies. So whether you aggregate the data by 5 minutes, 10 minutes, half an hour, a day, 5 days, 10 days, and so on. And again, do you get different impressions? And the answer is yes, you do. You get a very different sense of the temporal trends in the data. Another area is kind of like how comprehensible and usable are dashboards. And we've spent a lot of time on this. We've spent a lot of time looking at data literacy and interviewing people and talking to people. And the main issue for our dashboards is that for the general public, they're just too complicated. They just don't have sufficient levels of data literacy to be able to interpret the data in a meaningful way. Now, if these dashboards are public facing and they're meant to aid public's choice and decisions, but a large chunk of the public are not necessarily have the skill set to make sense of the data, then this is an issue. And so we've been looking at ways in which you can do that. So we ended up splitting our dashboard into kind of four ways. We have data stories, where you don't just get a graph, you also get some text that tells you how to interpret the graph and so on. So you get a story around the data rather than just the data. We have tasks, which is if you want an answer to a particular task, then you get certain kinds of data displayed, and then tools, which are kind of aimed at a more advanced user, where they can kind of set the parameters and fiddle around with the analytics and so on. So we kind of try to push different types of users into different interfaces onto the same data within the same dashboard. But clearly, if the dashboards are to have issues of literacy, then that affects their use and it also affects their utility. So there's a whole series of issues there, practical issues around things like navigation of site, the use of the tools, and then the data analytics literacy part of that. And even those people working in policy who might be a bit more used to using these analytics don't necessarily always have the levels of data literacy that they think that they do. And then there's questions around the kind of the politics around what are the actual uses of these data dashboards and how are they applied in practice. So they're typically used in three ways by cities: for monitoring performance and managing of urban services, for contextually understanding and formulating policy, for creating public knowledge and producing counter narratives. They can be used tactically, they can be used symbolically, and they can be used politically. So they can be used in different ways. So there's a whole politics into how this data is then used to make decisions and shape public opinion and to do things. In European cities, they tend to be used contextually, so they're often used in relation to other kinds of data and so on. In US cities, they're often used very operationally and much more in a kind of new public management style. So you'll find in some cities they actually have dashboard rooms. So this is from Baltimore. They have a weekly meeting where they review the dashboards and they review the performance of the data for every city department. So every city department is shown their data and they're asked to account for it and so on. The city score is actually from the city of Boston, and they're measuring various kinds of indicators on a daily, weekly, monthly, and quarterly basis. And they're using basically anything below 1. If you get to a quarter below 1, you will actually your department will get a visit from the mayor, and you will be asked why you're not performing as you should be and what you're going to do to rectify it. So it's very much a performance management tool. interestingly about this tool is this is given to the public, and you're just given these numbers, but you're given no information on how you to interpret these numbers. So, you know, I assume that they must have been some kind of stuff. You know, I had a whole conversation with the team who invented this, and kind of said, well, what are they? Are they like the standard deviations or something? Like what is this? How am I meant to interpret this? You give me nothing to interpret this. I'm just told above 1 is good and below 1 is bad, but I'm given no information on the formula or the data that underpins what I'm being presented with. But I know that decisions are being made in the city based on this data. Okay. And then lastly, just on ethics, you know, so how can we ensure that urban science dashboards are used ethically? And there's a whole bunch of various issues here around privacy, around the level of data that's being produced, often indexical data. So it's linked to, you know, if you've got an automatic number plate recognition, it's linked to individual cars. If you've got smart card scanning, it's linked to individual cards, and so individual people, and so on. So this is not the data that's displayed. It's often not the data that's given to researchers, although it can be under NDAs and various kinds of confidentiality clauses and so on. But there are questions here around privacy and around how that data is then used to make decisions that affect the people that the data refers to. There's questions around ownership and control, around, you know, who gets this data, how it might circulate in data markets, and so on. Questions around how it feeds into surveillance capitalism. So how is this data monetized, and how are urban science solutions feed into surveillance capitalism, feed into monetization of the data? Questions around social sorting, redlining geodemographics. So this is segmenting populations to receive different treatment. I talked about targeted area initiatives before. That's a kind of form of social sourcing where we've identified an area that might need some intervention. Social sourcing can be very positive and negative. So you could make decisions to disinvest from an area as opposed to invest in an area. Things around predictive profiling and anticipatory governance. So feeding to things like predictive policing that might target particular neighborhoods or target particular communities and so on. Questions around nudge, so nudging people to behave in a different way. And again, there's questions here about, well, who gets to make the decision, who is nudged, how they're nudged, why they're nudged, and what they're nudged into trying to do. All kinds of politics involved in that. That's not a neutral. None of these forms of governance are neutral forms of governance. Question around data security. So what happens if this data ends up getting breached and ends up circulating, and so on. And then questions of control creep. So data being generated for one purpose now starting to be used for another purpose, and so on. Actually, a good example for that is Trace Together in Singapore, where your app was, for COVID tracing, was launched on the basis of it would only be used for public health. But I think back in January or February, the data was used in a murder trial. So it's a clear example of the data creeping into a different use afterwards. And you often find that, so data in smart city technology is starting to be used in policing and security, even though it was never designed for that in the first place. And obviously a lot of kind of urban science, data science is producing some of the fundamental knowledge and ideas that feed into this. So the algorithms that are used to work out how to do social sorting, or how to do redlining, or how to optimize geodemographics, or how to optimize traffic on a road network, and so on. So the research is not neutral in the sense that the applications that can come off the research are not neutral. They're designed to implement various types of management and governance in relation to whichever regime is seeking to do that. I'm going to skip that one a bit, but basically that the argument there is that we tend to focus on ethics rather than focusing on justice. So we tend to focus on a very kind of technical, procedural way of complying, as opposed to thinking about the kind of the wider politics and ethos around what the science is trying to do. So this is just my conclusion side, really. So what we've been trying to do in some of our research is develop some of the technical tools, but to also be really critical about what it is that we've been trying to do and what it is that the tools that we develop do. So what are the kind of the politics and practices involved in building these technologies and in how they're then subsequently used in trying to manage or govern the city. And then thinking about, well, can we think of can we change the epistemology of the approach? So we're not saying we should discontinue doing urban science or computational social science. We think there's value in the work, and it produces useful knowledge and insights. But at the same time, there are various shortcomings and there are various issues that need some critical thought and redress. And so, can we shift the epistemology into a kind of a different register, really? And the way we've been thinking about this is kind of learning from people who've done this previously. So the kind of shift from GI science to critical GIS, the development of things like radical statistics, things like feminist data science. So none of them throw the thing away. It's data science, but with a critical feminist approach. It's GIS, but with a critical kind of ethos and reflexivity involved in it. It's statistics, but it's statistics used for public good. So it's trying to kind of shift the reference frame for how we think about how we operationalize and practice using these kinds of techniques and approaches. So these approaches, those approaches all employ quantitative techniques, inferential statistics modeling, simulation, and so on, but they're mindful and open around their shortcomings. So they draw on critical social theory to think about how the research is being conducted, how sense is made of the findings, and how the knowledge is employed in practice. They take really seriously issues around data veracity, data politics, algorithmic power, ethics, and justice. They tend to try and do this in a way that's much more reflexive. So it involves kind of critically interrogating what you're doing and actually trying to identify what the shortcomings or what the problems are, and then thinking through how you can kind of ameliorate and mitigate in relation to them. And they're quite open around their own positionality and their own situatedness. So they'll publish what the shortcomings and so on. They'll publish what the politics and practice are. They will let you know the context in which the method has been undertaken and what the issues around it are. The analysis tries to be more contextual, so it doesn't kind of cleave off kind of politics, culture, history, and so on, but it tries to frame the analysis within them, and to make sure that I guess kind of happens. And it's very cognizant that the city is this really contested, messy, contingent set of places and not just systems. And the various problems within the city are not just going to be solved by technological solutionism, which basically means, you need this more holistic approach where urban science can be part of the solution, but it's a part of the solution along with other kinds of analysis and other kinds of interventions, whether that's fiscal policy, community development, and so on. So urban science might be part of the answer, but it's not the answer to understanding what's going on in cities. And it's not the case that urban science will or should replace urban studies. It's how they can complement each other that's actually really key. If you want, the slides can be made available, and people. So I'm not expecting people to kind of run through this, but if you want some selected kind of sources around this, then I've kind of provided a few that the talk's kind of based around. and then that's me finished. I've no idea how I did for time, but I presume I'm over.
You're doing fine. Thank you very much. That was a very rich keynote speak. I don't even know how to summarize it, but personally, I think in terms of dashboard, in GS, we now can quickly generate something with the open data, but that quickness in terms of generating the dashboard definitely does not mean that the dashboard is perfect. And as you have mentioned, there's quite a bit of these issues to think about. All right. So we have some time to raise a question to Professor Kitchin. Is there anyone from the floor who wants to raise a question about anything from the keynote? Okay. So we have the first question coming from Gilherm. Sorry, I don't know if I pronounced your name correctly. Okay, so basically he has two questions. First, with regards to the metaphysical problems, have there been experiments that use data sets that capture values or emotions using natural language processing from sources such as newspaper, social media? So that's the, yeah. And most of the data examples you provided come from the transport engineering. So that's the first question. The second question is, since the concepts of dashboard and data for urban science are conflated, where one ends and the other starts. So that's the second question.
Yeah, I mean the first part of the question kind of actually kind of illustrates my part of my problem. Like metaphysical aspects of everyday life are, you know, they're your kind of your feelings, your values, your opinions, your beliefs, your unconscious affective everyday experience of being in the city. And the typical way you would try and approach those kinds of things would be through a much more kind of phenomenological kind of approach. And you're just simply not going to be able to replicate that using natural language processing based on social media, or semantics kinds of analysis based on social media. I mean, basically, the solution provided there is to try and capture that kind of thing through an urban science kind of, or a computational social science point of view, which kind of misses the kind of the metaphysical richness of being, basically, you know. And I just don't think it works, and is unlikely to ever work. It needs a different type of solution, which is ethnographies and its observation and its interviews and spending time with communities, being embedded within them and so on. And you just can't replicate that kind of richness of data through mining tweets. It's just a total misalignment of what you're trying to explore and the method, basically. I mean, the second one, in terms of conflating dashboards and data for open science, well, nearly all of the data used in the dashboard are pretty much the same kind of data that goes into urban science. You know, it's data off of all those kinds of systems that I was talking about. I mean, the dashboard itself is a fairly weak form of urban science, in that you're not necessarily doing kind of simulations or modeling or statistical analysis. It's more visual analytics and display, and I guess more towards the urban informatics end of urban science than modeling, statistics, forms of urban science. But typically the data are urban big data, and they're the same kind of data that goes into both. I mean, one of the reasons for talking about the transport is because if you're doing this in an open data set, so our project was open science, open data, open code, open everything, and so the data had to be open, and everybody else had to be able to access the data. And there are actually very few kind of urban big data sets that are open data, and certainly in the Irish context, there's few, and they're all transport or environment. They're not really in any other domain, so you end up kind of stuck in those domains. And for all the other domains related to cities, whether that's economic or labor and work, or it's education or social services or whatever it might be, you end up relying on administrative data and other government data that might be at best monthly, quarterly, or yearly, and you don't have the real-time data. Yeah.
Yep. Okay. So Gilherme actually entered a second question. Can you see it?
I don't agree with it either. I think you'd be much better off going and doing household surveys, or going and interviewing people, or doing an ethnography, rather than, you know, you know, these kinds of big data studies should be complementing rather than replacing traditional ways of which we go and generate this data. And you would get much more insight from doing this. In some cases, some of the data is problematic. You know, some of the new ways of doing things are really problematic. A good example actually is in relation to transport again, where I remember I'm going to go back to Mike Batty again, just because I had a conversation with him about this. So, you know, we were talking about some of the data he had in London, where he had 2 billion tap in and tap outs, like 2 billion tap in and tap outs for a couple of months in London from the underground system. And he was actually saying to me that the travel survey that was done in person in the underground with people interviewing people, gave way better data than the 2 billion data points, because on the 2 billion data points, you don't know anything about the people. So you don't know their age, you don't know their background. All you know is tap in, tap out. You know their route and you know their way through the thing, but you don't know anything around their demographics. You don't know anything about the purpose of their trip. You don't know any of the important contextual data that would allow you to draw useful insights. And so the small data study was actually way more informative than the big data study. And I think it's the same kind of thing around this kind of lived experience. You know, the key thing here is, what question are you asking, and what do you need to know, and what is the most appropriate method to do that? If the most appropriate method is qualitative, then you do that. If the most appropriate way is quantitative, then you do that. The most appropriate way is urban big data, that's fine. If the most appropriate way is small data and high quality representative sampled data, then that's the way you go, you know? So I don't think it's the important thing is the question that you want to ask and answer. And that should dictate the method, rather than the approach and method dictating what questions you ask.
Okay, great. I think one of the panelists, Elaine, has a question. So Elaine, would you please unmute yourself? Yep.
Yeah, hi Rob. Just
Hi,
coming online to say hello to you. I have a question to ask about, first of all, I want to say thanks for a very succinct review of the field, and just making it so accessible so I don't have to go read up all the different articles that you've mentioned. But I'm wondering about the engagement with theory, right? So you did mention that this approach, it's more it's contextual, it's framed theoretically. But from existing work that has been done, have you observed whether this kind of work really has the potential to challenge existing theories or produce new theoretical ideas? I'll turn off my video now.
Yeah, it's a good question, actually. I mean, some people would say that that it has, right? So some of the stuff around trying to produce new urban laws might have fed into some. So the kind of Betancourt kind of work might have fed into some kind of policy circles or thinking around kind of infrastructure planning and so on, or might feed into or some of the work around kind of transport modeling feeds into transport policy kinds of work. I'm not entirely sure that we've really got new theory, like new substantive transportation theory coming out of big data. Some theory that replaces or completely supplants existing theory. I'm not convinced that has happened as of yet. I'm sure people will tell you in things like medicine, where you've got big data going on in medicine, that probably has happened. Like the case in point around things like vaccine, some of the vaccine rollout now and the modeling went on in relation to that, and the data collection and so on, which, if nothing else, speeded everything up massively. But not necessarily in the urban domain. And again, I've seen that critique by others, kind of saying, we're putting a massive amount of money into urban data analytics. Like every national funding agency has kind of tended to prioritize it. There's huge amounts of money going in, and are we really getting breakthroughs? Fundamental insights that we never had before. Are they genuinely happening or not? And I'm not sure that that is the case. And we're certainly not seeing a paradigm shift in thinking. It is more of an extension of what was already there. So it's an extension of kind of quantitative geography, GIS, all those kinds of things I said near the beginning. It tends to extend them rather than replace or supplement them. That's just my view. I don't know if anybody else can come up with an example where our thinking has been radically changed because we've used big data.
Thanks very much, Rob. I think that's a sense I get as well, that to some extent, or to a large extent, this kind of approaches still seem quite deterministic, rather than being able to capture the fluidity of the world. So thanks for the very balanced sort of assessment you provided through your presentation in this discussion.
Yeah,
it
definitely is feeding into kind of urban management, though. The work is definitely feeding into things like intelligent transport systems and transport models that then are used to calibrate those systems. So it might not necessarily be shifting our theory, but it is shifting some of our practice, because all of those smart city systems, and there's more and more of these systems being rolled out. So things like predictive policing that wasn't there 10 odd years ago is being driven by this data and this data analytics. Although interestingly, a number of police forces in the US have now discontinued using it on the basis that it doesn't work. It hasn't actually improved their policing rates at all. It's had marginal effects. But it definitely has changed practice on the ground, and it has changed policy approaches and so on. But it doesn't necessarily have changed our fundamental ideas and thinking about things. That's my view.
Thanks, Rob.
Okay, let's see if there's any other question. Okay, since we're already 8:30, I think I would just add one more question if there's no other question, and then we'll probably would have to thank Rob. Okay, so I think the previous two questions, well, the first thing is that kind of confirmed this, I suppose when we look at data science, there's always this I would say this is so what questions. So we put in big money and get the big data. And then what exactly are we trying to solve, or actually what are the theory that we come up? I just want to ask this question, probably more coming from one of the keynotes in the past 2 days. So they were talking about the shifting from big data to broad data, right? So broad data meaning that the veracity of the data is become much, much bigger. So earlier you talked about dashboard. There seems to be emphasizing on lack of the contextual information, but for looking at urban issues or urban dynamics, or in the trendy term in GIS science will be human dynamics. So for this kind of thing, we do need to go from spatial to placial, looking at contextual data. So I was just wondering, coming from advancing computational social science, is there anything that we can anything that we can add to the dashboard, or to incorporate into the dashboard so that it would have more contextual information?
My answer would be no, and it's basically be on the basis of what dashboards are designed to do. Mm-hmm. So I think if you want the more, how to put this now? You see, part of the problem is dashboards is that they're facing the public, and they're already too complicated. So dashboard facing the public, you just need to make them as kind of simple and as comprehensible. And the context comes from telling data stories, and it comes from putting some information that helps you interpret what's happening. So you can put some contextual information there, but it's going to be limited. It's not going to be deep contextual, historically grounded, or like, you know, it's going to be snapshots and so on. And so you need a different mechanism if you want to do the kind of thing you're suggesting. Now, it's different in the operational control room. Like if I go, like we did an ethnography of the control room in Dublin. So we put a researcher sat in the control room, watching the controllers and interviewing them and talking to them and chatting away and so on. And they have a lot of experience, and they have a lot of contextual knowledge. So when they're using the dashboard, they're often using it having spent 10 years managing traffic in the city. They're familiar with traffic policy. They're familiar with the history of solutions they've tried in the past. They're familiar with the traffic models that they've run and then used to calibrate the system. They have a history of having to deal with unusual events or crisis events, or dealing with exceptional events like a major protest or a major sporting event or something. And so they do actually use it with contextual knowledge in a way that's different to others. So within the operational control room, but that knowledge doesn't necessarily sit within the system, it sits with them. And I don't know how to encode it into the system that it could inform other people, because it's like it's embodied and it's in place. It's not something that it has to be kind of learnt and experienced in a way, and or has to be learned over time. It can be learned over time through like reading or getting a history of what's going on and so on. So yeah, I imagine it's quite difficult to put in the system otherwise, if that makes sense.
Yep, that makes a lot of sense. All right, so so we're already 8:34, so about 5 minutes over time. Last chance, anybody has any questions? Okay.
One of the ways I try and explain, so people come, well, you seem quite critical of them. Why do you build them? And my answer is always, I build them to destroy them, to try and build them better. I think that's what people who are working on this should be doing. If you're a researcher, you should be highly self-critical, and you should be trying to find all the shortcomings so that you can work out how to better address and solve them. So that's what we've been trying to do. We've been trying to improve dashboards by pulling them apart. Theoretically, conceptually, empirically, technically, instrumentally, however you want to do it. But that's how I think you move things forward.
Yep. Okay. On that note, I guess we will conclude this keynote, and let us thank Rob Kitchin for this very thoughtful and very rich presentation on the dashboards and all the issues related to that. All right. Thank you very much.
Great. Thank you.
Thank you.
Thanks, Rob.
Cheers.
Yep. Cheers. Bye-bye.